So this is a basic car. Now this is one that I built myself, following no set building instructions, but there is a car build in the app, and I'll show you that in a moment. But essentially I just added the motor, very similar to the fan. So that's why the fan's really good to learn that spinning mechanism. And all I did was attach it here. I added a cog around the rear axle with an elastic band. And that's going to allow it to give me movement. And I added that same sensor on the front. So I've got the motor turning the axle. And it's always good to add a little bit of competition at the classroom. So I like to task the students with having a race. Who can build the fastest robot? So if they follow the build in the app, and I'll show you where that is now actually before I continue. So I'm going to click here. I'm going to click here on build instructions. And I'm going to click those the four squares to go back to the beginning. Now, you can use the Milo science rovers for this. They are all driving robots if you wanted to. You could also find another driving robot here under the hourglass, sorry, the light bulb. Click on the build and a drive robot. See this racing car one here? I can select that. And you can build a race car like that. That one looks pretty cool too. It's a much prettier version of what I have built. This one only gives you a view. It doesn't give you a set build instructions, but once you're a little bit more confident, you can see it. If you want those set build instructions, the Milo Science Rover is a good one to do. And you'll probably find like this one here under speed. This is essentially that project. And it will give you some build instructions. This one gives you a little video on what it could look like and a little bit of sample code on what it is that you should expect from the end of it. Notice when your hand is in front, you tap, the robot moves, and there's code there to show you how to do it. So this one will come with build instructions if you want it. Follow that process through, you'll get something that looks like my robot here. So yeah, so it's very, very similar, just not as good looking. So it's got the front wheels and the axle. So to make that, to code that, you could essentially use exactly the same, but to get the speed out of it. Now this is not something you'll find necessarily in the build instructions. So if we have a close look here on what I've done, and I don't like to tell the students this straight up, I like to let them discover it themselves. A bit of discovery learning is a very powerful tool in the classroom. If you put a big cog, and I've put a very small cog on the rear wheel, see this little yellow one? And I've put a larger cog here on the motor. It's to do with the distance that this has to travel on the outside is greater. So this will spin much faster. The speed here of the outside moving is much faster than the speed of this little one. So you will get a faster driving robot. It's all around gear reduction. So it's not a bad, it's kind of a good one, I would say, for stage 3 class, learning about forces, to look at some of this gear reduction. You can, if you add a second gear reduction to that, you'll make it go even faster. But that's where that discovery learning and that experimentation that you want to build into your classroom, where you all have the same target, but hopefully you will get 10 different versions of the same thing. It's a really great way then to reflect on each other's work and give them some tips. So the code to make that robot work would be exactly the same as what you saw. So if I jump back into the app real quick, and we've got the same code here. Now this is a different robot, so I am just going to tap here on at the top of the screen. I am going to disconnect from that robot. So the next thing I need to do is connect my robot. This is a different robot as mentioned, so I press this button, the light starts flashing, and over in my software here, I can see a different named robot has appeared. Now I have tapped on the word Bob, and he is connecting, and he'll turn green to show that we are now connected. So in the app, and I'm just going to hit play. It's the same code as before. It's when it sees movement start, and when it sees movement again, stop, or when it detects an object. So essentially, I might just put a little tower of smart bricks in front of him. And so I've got a little tower of smart bricks here in front of my robot. When I press play, he should, in theory, drive until he sees, he'll wait and see when I hit play, he'll wait until he sees movement, which will be my hand, and he should, in theory, when he sees the robots. Now something interesting has happened, which is good, which is a great thing to happen in the classroom. My robot's trying to go backwards. There's an error in my code. And this is something that the students will have to come across over and over and over again. So simply, a change in direction is required to make this robot work properly. You could re-engineer it to move a different way, but I am going to just drag in a directional change. goes. So I've added in that directional change there to the robot now. So the code is currently running. It is waiting to see movement, and when it sees movement, it starts moving forward until it detected an object, and now it has stopped. When it sees the movement again, start and stop. I could take that away. Oops, you can't see it anymore. So start, stop, stop. That's kind of cool. And he's going to do that forever on an infinite loop. So I'll need to press stop on my code to make him stop doing that. So there's just a couple of ideas for a first build. Start with a cooling fan. It's a really great project to start with. It's simple, it gets immediate response, and the students can then start exploring and then go into using a sensor for the first time. And then after that, your next build could be doing something like this car, where it's a little bit more open-ended and they can bring in some of that knowledge into their project. So good luck, and in our next video, I'm just going to show you a few other project ideas and some other directions you can move in when building and engineering with Lego.
This video is part of a series of support videos all about the kit that you have borrowed. To find the other videos in this series, head to the Learning Library and visit the kit page for the equipment you've borrowed. You can also find the full list of support videos for all of our kit on the YouTube channel. You can also join us in the Yammer community. If you have any questions or you'd like to ask teachers how they've used the equipment in their classroom, then why not join us on the STEM T4L Facebook community? It's a closed group. You can ask teachers how they've used the equipment and also share the work samples that your students have created.